everyone, and welcome to the webinar. My name is Charlotte, and I will be monitoring the chat and helping if you have any technical issues throughout. Today, we will be focusing on building custom transformers with FME. Your host for today will be Martin Lufkin, and I'll hand over to him shortly. Before we begin, I'd like to go over a few housekeeping items. You have all been placed on mute. However, we welcome your comments and questions by typing these into the question panel. We will address these at the end of today's webinar in the Q&A session. If we don't get a chance to answer your question, don't worry, we'll follow up with you afterwards. Finally, today's webinar is being recorded and we will share the link with you after the webinar via email. Okay, over to you, Martin.
Okay, thank you very much. Good morning, welcome to this webinar. Thanks for joining us. My name is Martin Lufkin. I'm one of the FME consultants here at One Spatial. And today we're going to be looking at building custom transformers. And I'll be sharing some of the great uses and extra functionality that can be found by building and using them. So just to start, a very, very brief introduction to us at One Spatial. We work with data and provide software and solutions that help our customers manage their data, primarily spatial data. And we have a number of different offices around the globe with our headquarters here in the UK based in Cambridge. We work with customers primarily within the government and the utilities and transport sectors, and we have a number of different technology partners, as you can see in the bottom left, that we work very closely with. In particular here, we can see that we're platinum partners with Safe Software, the producers of FME, and we've been reselling and working with FME for many years now. So, to start with, I'll just give a brief summary of a few key changes that have happened with FME over the past year. I'm sure you're all aware by now, but the FME suite of products have had new logos and also new names. So I just want to reiterate these. FME Form is the desktop product. FME Flow is the server product, the enterprise level data processing, and FME Flow Hosted is the enterprise product that's hosted in the cloud. And I apologize now if at any point I call things by the wrong names. It'll take me a while. It takes me a while just to retrain my brain after using FME for just over 12 years now. But thankfully, the applications themselves are unchanged. So we've still got FME Workbench to build our workflows. We've still got the data inspector, the licensing manager. And we've also got a new application called the Transformer Designer. We're not going to be covering this off in this session, but it's worth mentioning that this is new for 2023, and it's where you can build FME packages. And these are Python based, and they can add additional functionality beyond what is possible within standard or even custom transformers. These are quite exciting, and I expect that we're going to see some future webinars and articles on it very soon. So let's jump into the topic of this webinar. We're going to be looking at custom transformers within FME Form. So whether you've used them for a while for a particular purpose, or you're totally new to the concept and don't even know what they are, I hope there'll be something for everyone in this session. We're also going to be covering off embedded and linked custom transformers. We're going to be looking at how we can use them in a looping mechanism, as well as touching on publishing and retrieving them from the FME Hub. So to start us off, what exactly is a custom transformer? A custom transformer is a connected sequence of standard transformers which have been condensed into a single transformer. So as you can see here, there's 10 or so transformers here on your canvas, and you've brought them down and you've condensed them down to just one green transformer at the bottom there. So any sequence of existing standard transformers and additional custom transformers can be turned into a new custom transformer. So why use them? So these are useful for consolidating transformers on a canvas. So it might be that you've got a canvas that looks quite busy. There's perhaps lots of functionality going on that you can't really you kind of want to hide. A little bit like bookmarks, you can condense them down into your custom transformer. These can also be used multiple times in a workspace. So there's, as you can see in the bottom right here, you've got multiple instances of the same custom transformer that are doing similar logic for different data sets. It can be shared with other colleagues as a standalone file. So if you've got a bit of logic that you want to be able to share with people, you can save it off as an FMX file at the bottom here, and you can share that with people. It can also be published to the FME Hub for a wider use. So if you think your functionality could go global, you might want to use it. You might want to publish it to the Hub for more use. But it also adds additional functionality. So looping is something that we're going to cover off a little bit later on, and it's functionality that's only accessible within custom transformers, and it's a really useful thing to be able to do. So let's jump into FME Form and show how these work. So creating a new custom transformer can either be done through the transformer menu list, so up here at the top, transformers, create custom transformer, or by using Control-T if you like your shortcuts, or by right-clicking anywhere on the canvas and using the create custom transformer option. You can either start with a completely empty canvas, or if you wish to populate a custom transformer from existing objects on the canvas, make sure that they're highlighted first. This will pre-populate a new custom transformer with those existing objects and add any incoming input and outgoing output ports that are required depending on your initial selection. So let's see this in action. So we've got our workspace here, and just to talk you through what's happening here, we've got a creator, and let's say we're going to create 10 instances here, 10 features, and we're going to give them all a creation instance number. So this will be incremental, and it's running through an attribute manager, which is changing the creation instance from being 0 to 9 to being 1 to 10. And we've got our little test filter here to say, okay, I'm going to filter out the features that are bigger than 10 or equal to 10 and send them through one port, and all the rest of them saying not there yet. And we've got on the end, we've got a couple of loggers. So this logger says this is more than the 10th feature, and this is logging off to the translation log. And in the translation log for these, not at the 10th feature yet, and it gives some information about where we're up to with those features. And if we just run that, we run it in the cache mode, and it's pretty quick. And we can see that we've got our 10 features. We've renumbered them to 1 to 10, and we've got 1 coming through as our 10th feature and 9 coming through as our not there yet. In the translation log, we can see we've got not there yet, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the 10th one is coming through the other logger. So when we create our custom transformer, we're going to initially be presented with a dialog box. So let's create one based on these 2 transformers here in the middle. So it's asking us to pre-populate some basic information on our new custom transformer. Transformer name is required, ideally without the use of spaces. So let's call this one webinar custom trans. And we'll give this a category, maybe attributes. And a description is usually advisable, especially if you're going to intend to publish this to the FME Hub, or even just share it with colleagues and clients. So let's just say custom transformer, if I can spell, to find greater than 10th feature. And we can use the markdown. If we tick the use markdown button, it allows us to add more extensive documentation, and it also supports rich text formatting. This really is a must if you're publishing to the FME Hub, and it can be a great place to store version history of a transformer, as well as legal documentation if required. So once the dialog box has been created, a new custom transformer definition will appear as a new tab on the canvas or in your workflow. Here we can see inputs and outputs similar to readers and writers, but appearing in green to denote there being a need for an external requirement for this custom transformer to work. If we just flick to the main canvas, we can see we've got two tabs now. If we flick to the main canvas, we can just see now a single transformer in the place of the transformer selected, with inputs and output ports, just like a standard transformer, correlating to the inputs and outputs we saw in the custom transformer tab. We've got two outputs, one input, and we've got our one input and two outputs here. If no transformers were initially selected, a blank custom transformer with a single input and output will be generated instead. So we could just do that as well. Let's just put a test in here. We hit OK. We'll see we have another test, another custom transformer definition, and this time it's got nothing in it, and it's just an input and output. So you could create it that way too. So once created, a custom transformer behaves in much of the same way as a normal transformer. So let's just run this and see what happens. You see we get the same results, and in this case we've got it cached throughout the definition as well, and we've got the same results. So just like normal transformers, multiple copies of custom transformers can be used within the same workspace. So if you do need to repeat certain parts of logic within a workspace, it becomes much easier to maintain, as you only need to edit the underlying definition, and it will update all instances on your canvas. So if we have two instances of the same custom transformer here, you can see we've still only got one definition and one place to edit and change anything, and it will be reflected in all of the instances. Editing the definition is very similar to working in the main canvas. Transformers can be added or removed, and settings changed as required within the custom transformer tab of your workspace. The inputs and outputs are by default named according to their connected transformer, but these can also be edited as required by either right-clicking and hitting rename, or by opening up the cog. So let's just change this one, and let's call this one input instead. These will also correlate to what it looks like on the main canvas. So you can see the input has changed, the name of the input is now changed, so it's dynamic across both of those two tabs. Additional inputs and outputs can also be added after the initial creation of the transformer by right-clicking on the canvas and selecting Insert Transformer, Input or Output. As we can see, these also appear. If we connect that to that, for example, these also appear on the main canvas with two inputs here. So it's fully dynamic. So attribution and user parameters. So custom transformers can be built to receive values from attributes in the same way as any transformer. Because a transformer can be used in multiple places, this has to be designed to make the inputs as dynamic as they need to be. In this example, the attribute manager used within the custom transformer is expecting an attribute called creation instance, which is present on the dataset, which was originally used to design the logic for this transformer. If this transformer is used elsewhere, where creation instance does not exist, the custom transformer will be marked as incomplete. So as you can see here, if we had another creator, but instead of calling it creation instance, we called it feature ID, the transformer is still incomplete. This is because the creation instance within a custom transformer, in this instance, has been converted into a user parameter, especially for this transformer. And by default, the value of the creation instance attribute has been assigned to it. So to make this work for a secondary custom transformer, it needs to know which attribute to use in the creation instance user parameter, set by opening the cog and changing. So you can see here in our definition, we have a user parameter called creation instance, And by default, it has the value of creation instance from the attribute. In order to change, to overwrite that default, we need to go in and we need to say, well, we're going to use feature ID instead. The user parameter is still called creation instance, but it's now taking its values from the feature ID. So this is really, really handy, especially as now this custom transformer can be used in the same way on differing data sets. As soon as a custom transformer is used in more than one place, you'll also need to consider automatic parameter and attribute handling to allow each version of the transformer to be supplied with different values depending on the incoming data. Once a custom transformer is created, any existing parameters that were used as part of the transformer settings will be brought automatically into the navigator of the custom transformer definition. This means that when the user is prompted for a parameter to be set, this won't follow through into the custom transformer unless it is defined in the log. So let's see an example of this. If we've got our, say we're going to have a user parameter for our increment. So instead of us having 1, we're going to create a user parameter for that 1. So let's call this increment. And let's give it a default value of 1. And let's bring that in, and we'll remove the 1. Excellent. Now, so in our definition, in our custom transformer definition, we now have another user parameter called increment, and it's set to 1 by default. Now, if you go back to main, if we run this workspace fully, we'll see that nothing's changed, and it's using that one value to set the features accordingly and going through to the correct loggers. But if you notice there, it didn't ask me for any parameters to be set, because by default, it's just grabbing the default value. So increment is set to 1, and we can set that to 2, or we can set that to 3, and we can set that differently depending on the instance of the custom transformer. This one might want to be 1 instead. If we wanted to use a user parameter there, we would have to also add that to the main canvas. So we would have to go into our user parameters here and have an increment. An increment main. We might want to call this main dataset increment. And let's leave the default value off. Now we've got it in our main canvas. If we go into our parameters for our custom transformer, we can set this to our user parameter that we've just created, increment main. And now when we run it, it will ask us what we want that increment to be. Let's call that 3, and we'll probably see this 3 come out here. Okay, so in order to use the user parameters, we need to set them in both places. But this is quite exciting, because suddenly we can maybe create different user parameters for different instances of our custom transformers. So we could have another user parameter called minor dataset increment, and have a different increment for each time that we for each instance of our custom transformer. Let's move on to loops. So loops are a great way to repeat a section of transformation logic multiple times without having to duplicate that section on the canvas many times. So loops are only allowed in custom transformers. This is another good reason to use custom transformers. So as features pass through FME one at a time, a feature will also loop through a custom transformer one at a time as well. So in order for that to be worthwhile, something on that feature has to change each time it loops. Otherwise, it's just going to loop around forever. So let's give this a go with loops. So let's remove some of this user parameters stuff that we did. Let's go back to 1. And let's remove our user parameter there. So we've got our standard custom transformer there with 1 and 9, great. So if we go into our creator and maybe just create one feature this time, and we can run that and we can see that it will come out of the not there yet port because it got the creation instance of 1. What we're going to do is we're going to go into our custom transformer definition, and we're going to simply right click with our custom transformer, select the insert transformer loop, and you'll see that it asks for where the loop should return to. So we're going to return it back to the input, and we're going to connect that up to our not there yet. So as you can see, the feature is going to go through, it's going to come through to our loop, and then it's going to go back round. As it comes back round, the creation instance is going to add 1 to the original creation instance, and it's going to add 1 each time. So it's going to loop through until it gets to the 10th feature, and then the 10th feature will come out of the top port, which isn't being looped. So we go back to our main and we run this. You'll see from 1 creation feature, we've got 9 coming out of the loop. They're not there yet, and it loops back round as well as coming out of here, and it comes out of the top one, and we can see in our log that we've got feature 1, 2, 3, 4, 5, 6, 7, 8, 9, and our 10th one, all done from just one creation instance. So we loop until a specific condition has been met. So this might be a maximum number of iterations, or it might be a different condition like an area size or a certain value has accumulated, like this one. So this is really, really powerful, but it's strongly advised to be careful when it comes to group-based transformers such as the aggregator or the statistics calculator, ones that hold on to features until all of them have been received. This can cause, as you can imagine, this can cause quite potentially big problems, and it's more than likely going to result in an error being returned. There are instances where those kind of transformers can be used, but it's pretty niche. And unless you're doing something very specific, it's not really recommended. So let's move on to the different types of custom transformer we can see. So there's 2 different types, and we're going to take a look at both types and to see how they're different and how we can create both types. So the first type is the embedded custom transformer. And as we've been seeing, an embedded transformer is one whose definition is stored in the workspace itself. The ones that we've been creating so far have all been embedded custom transformers. So each instance of the custom transformer refers to that embedded definition within your workspace. So only the workspace in which the definition is embedded into has access to that custom transformer. So it's baked into the workspace itself. So the advantages here, it's easy to manage because you're in full control of what that transformer can do. There's no external files needed. The definition is, as I say, baked into the workspace, so it's good. And it's great for things like looping and parallel processing because you're in full control of that workspace. The downsides, sharing the transformer is difficult because there's no file to share with anybody and it's not been published anywhere. It's not so easy to maintain consistency for multiple users. So if multiple users have created maybe their own definitions of the average area calculator, and they all might be different but named the same, it's very difficult to maintain that consistency. The other type of custom transformer is a linked custom transformer, and this is one where the definition is stored outside of the workspace in its own file. So each instance of the custom transformer is linked to that definition or that file. Any workspace can have access to that custom transformer. So the benefits here are that it's easy to share and publish. There's a file involved and you can share that with anybody that you like. More authors can point to the same transformer, so you can maintain that consistent approach when you're trying to have a consistent function. The downsides: harder to manage the usage, so anyone can use it and maybe use it right, maybe use it wrong. Loops and parallel processing are more complex because you've lost the control over how it's being used. It's quite difficult to keep loops and parallel processing as generic as possible when you don't know necessarily all of the different use cases that it's being used for. So creating a linked custom transformer is fairly straightforward. We need to go into our custom transformer definition here, and we can just hit File, Export as Custom Transformer. It will not be available on the main canvas, so be aware of that. If it's grayed out, you probably need to jump into your definition. And when we go to Export Custom Transformer, it's worth bearing in mind there's different types of insert mode. Embedded by default is where it's embedded in your workspace but can be changed to linked if needed later. Embedded always. This saves the custom transformer as an FMX file, but when importing into a new workspace, it will save the definition on your canvas. So any edits made to the definition will not be reflected in the FMX file. Linked by default saves the transformer as an FMX file, and then when used, the workspace looks to the FMX file for its definition rather than the embedded tab, but this can be changed if needed. And linked always is where it's linked to the FMX file and will always receive any updates made to that transformer. So with those linked ones, be really, really careful, because any changes you make to it or anybody makes to it will be reflected in every other instance of the custom transformer, including other users. So we can version off our existing linked custom transformers. Simply right click and upgrade to latest version. Any summary annotations like this one in the bottom left will be updated accordingly. Remember to refresh the transformer gallery list with the refresh button to make sure that your form instance is picking up all of the latest versions of the custom transformer. And this is done down here at the bottom. Your refresh button will refresh your transformer gallery. Remember also, you can only upgrade to the version of the custom transformer that your FME form version is compatible with. So any functionality that is not in your version of form cannot be upgraded in a transformer. And finally, the FME Hub. So hub.safe.com. It's a great resource for linked custom transformers. There's over 1,200 custom transformers created by various FMEs all around the world. Verified and official statuses have been given to some of the trusted sources for these custom transformers, so you can sort by those. They're updated really regularly, so remember to refresh your workspaces to update the downloaded custom transform, the latest versions of those. There's also access to the FME Hub via the Transformer Gallery. So as you can see in that middle red box, the FME Hub, that's the same list of transformers as you'll find on the website. So if you know the name or you know what you're looking for, you can just do it straight away in your FME form instance. And also in the bottom left there, you see the quick add function. That's also linked with the custom transformers. So if I go in here and type UK, you can see there's a couple of one spatial built linked transformers here that are UK specific around phone numbers and postcodes. So you can use the quick add to add those in, and you can just click on them and they'll just appear. And that's it from me for today. I hope you found it interesting. I hope you found it useful. Thank you for your time. If you want to get in touch, please do contact us on fme@onespatial.com or support@onespatial.com, and also check out our events and webinars page. Keep an eye out for the next set of webinars that we'll be hosting. Thank you very much.
Thanks, Martin.
Thank you.
Right, okay, we've had a couple of questions.
Okay.
The first question is, if you create a user parameter first and then created the custom transformer, will the user parameter be in the custom transformer? I hope you got that.
Okay, yeah, so that kind of makes sense. So if you created your custom transformer already having user parameters within that to create the definition, then those user parameters will end up in the custom transformer. So just be aware of it. It will take the default value, so you won't end up with a user parameter still on your main canvas. You'll have to create another one there to be able to drive what value is in that custom transformer user parameter, because otherwise it will just take the default and it will just stay static. So just be aware that is likely to happen. So it's just getting your head around the user parameter usage across both custom transformers and your main canvas. They're slightly separate.
Perfect. And the other question we've had in is, where are FMX files saved?
Okay. So they are saved in documents. In your documents folder, you should have an FME folder, and within that FME folder, there's a bunch of different folders there, like workspaces, so default workspace locations and stuff. And there's a folder there called transformers. And if you open that up, there's some that's where your FMX files, if you choose to save them, that's where they'll end up being.
Brilliant. That's all the questions for today. So thank you, Martin, and thank you, everyone. We'll see you on our next webinar.
Thank you.
Thanks.